want to look at the different counting principles that we have, we'll start with the basic counting principle. Now, the idea behind the basic counting principle is that suppose we're performing two experiments. Now, experiment one can result in N1 possible outcomes. Experiment two can result in N2 possible outcomes. So we want to determine what are the total outcomes if we perform the two experiments together. And the basic counting principle says the total outcomes if you perform the two experiments together is just going to be the product of the outcomes of the first experiment and the outcomes of the second experiment. So if experiment one results in N1 possible outcomes and experiment two results in N2 possible outcomes, if you were to perform the two experiments together, the total outcomes would be N1 times N2. Let's look at an example. So suppose you want to combine a committee of sophomores and freshmen. So experiment one is that you want to select a sophomore, right? You want to select a sophomore, and now there are three sophomores here, A, B, and C. So there are three ways that you can perform experiment one, that is selecting a sophomore. And experiment two is that you select a freshman. The two freshmen here. So the number of ways that you can perform experiment two, I select a freshman. So now we want to choose a committee consisting of two people, one sophomore and one freshman. So to find the total number of ways we can form such a committee, now there are two ways to go about it. So see, so we have three sophomores and two freshmen, and you want to form a committee which has one freshman and one sophomore. So now there are two ways to go about this. One is that we want to find the total number of ways we can form such a committee. So the two ways to go about it is, the first is we list all possible pairs, right? All possibilities, right? Like, for example, one possibility could be you choose sophomore A and you choose freshman X. Like we have over here, sophomore A, freshman X. Possibility could be you choose sophomore A and freshman Y, like we have it. Another could be you choose sophomore B and freshman X, like over here. Then similarly, sophomore B and freshman Y. And then similarly, sophomore C, freshman X, like here. Then sophomore C, freshman Y. So these are the total. So one possibility is that if you want to find the total number of ways you can form a committee that includes one freshman and one sophomore, is you list all the possible pairs, and then from here you can see the total number of such committees we can form a 6 possible outcomes. The second way, which is a shortcut way, is that use the basic counting principle. We know there are two experiments. So we know the two experiments. The first experiment is that we want to select one sophomore. And the second experiment is we want to select one freshman. So the total number of ways we can do this together is that we multiply the number of outcomes of the first experiment, which is 3, with the number of outcomes of the second experiment, which is 2. So this would be 6. Right, so we'll get the exact same answer. So the total number of ways you can form a committee of one sophomore and one freshman is, you multiply the number of ways that you can select one sophomore, which is 3, multiply by the number of ways you can select one freshman, which is your second experiment, and that is 2. So then you get the exact same answer, 6 possible outcomes. So this is a shortcut way where you have two groups that have different number of outcomes, and you want to find in how many different ways we can combine them. So we had like one experiment or one group where we could select a freshman in 2 ways and a sophomore in 3 ways, and you wanted to see in how many different ways can we combine them. So the basic counting principle provides you a shortcut way of finding the total number of outcomes of performing multiple experiments together without having to list all the outcomes individually, like we had to do. Like we said, there are two options. You could either list all possible pairs and count them, or as a shortcut, you can use the basic counting principle to find the total number of ways you can perform different experiments together without having to list every possible outcome. Now let's look at another example. Suppose if we roll a dice, there's 6 possible outcomes, and if you toss a coin, there are 2 possible outcomes. If the dice is rolled together with a coin toss, then total there are 12 outcomes. Using the basic counting principle. So we don't have to list down every possible outcome that we say 1 head, 1 tail, 2 head, 2 tail, 3 head, 3 tail, and so on. So you could list all possible outcomes and combine those, but a shortcut way of doing this is to simply apply the basic counting principle. And we know the first experiment, which is a dice roll, can be done in 6 possible ways. The second experiment, which is a coin toss, can be done in 2 possible ways. So if you were to perform both of them together, then the basic counting principle says that the total number of outcomes are going to be the number of outcomes of the first experiment 6 times the number of outcomes of the second experiment 2. So you get 12 possible outcomes. So you don't have to list down every possible outcome. Now we can extend the basic counting principle to more than 2 groups or experiments, and this is what we call the generalized counting principle. Now say we have 3 freshmen, 4 sophomore, now we have 5 juniors and 2 seniors as well. And now we want to form a committee consisting of 4 people, 1 freshman, 1 soph, 1 junior, 1 senior. So here we have a total 4 experiments. And there we had 2 experiments. So you wanted to select 1 freshman and 1 sophomore. Here we have 4 experiments. You want to select 1 freshman, you want to select 1 sophomore, 1 junior, 1 senior. And the total number of ways we can do them together is, you just see, okay, the number of ways that you can select 1 freshman is 3. The number of ways you can select 1 sophomore, which you can think of as experiment 2, is 4. The number of ways you can select 1 junior, which you can think of the third experiment, is 5. The number of ways you can select 1 senior, which you can think of as the fourth experiment, is 2. So basically, based upon the generalized counting principle, the total number of ways you can select this committee is that you just multiply the possible outcomes of each of these experiments. So this is just the basic counting principle being generalized. So the generalized counting principle says that it's like a shortcut way where you can essentially where for two or more groups you can have different number of outcomes. Where for 2 or more groups, when we have different number of outcomes, it allows us to find the total number of different ways we can combine them without listing each outcome individually. We can apply the counting principle. So you don't have to list down every possible pair. You can just simply use the counting principle as a shortcut to find the total number of ways in which you can do multiple experiments together if you combine them.